In 1997, deep beneath the Pacific Ocean, something made a sound louder than any known marine animal. It was picked up by multiple sensors, thousands of miles apart. It rose in frequency, it lingered, then it disappeared. No vessel was nearby, no seismic event was recorded. Just a sound. The signal was detected by hydrophones operated by the National Oceanic and Atmospheric Administration. These instruments were originally placed to monitor underwater volcanic activity and to detect illegal submarine movements. Instead, they recorded an ultra-low frequency sound, later nicknamed the Bloop. It occurred in the South Pacific, west of South America. The sound was powerful enough to be heard across a distance of over 5,000 kilometers. It followed a distinct pattern, a rapid rise in frequency between 1 and 7 hertz, lasting about 1 minute. No known marine species produces a sound at that volume. At the time, its origin was classified as unknown. The recording remained archived for years. Later analysis compared the waveform to known natural events. In 2012, NOAA reported that the characteristics closely matched those of icequakes, fracturing and movement within large ice masses near Antarctica. The original signal remains part of a larger dataset of unexplained ocean acoustics, logged, stored, revisited. What happens next depends on how you interpret what you're about to hear.
The most grounded explanation is that the bloop was an icequake, large-scale fracturing or calving of Antarctic ice.
The acoustic data confirms it. Icequakes generate massive low-frequency energy that thrives in the SOFAR channel, allowing the sound to bypass traditional ocean obstacles.
The waveform comparison was suggestive, not definitive. Similar class of event is not the same as matched source, and that distinction matters.
The acoustic propagation physics are critical here. The triangulated location likely points to the general region of the source, but the SOFAR channel can distort the apparent point of origin.
Exactly. The sheer energy needed to reach hydrophones thousands of kilometers apart fits a massive ice fracturing event far better than any known biological source.
Especially with large iceberg calving events. Those can generate broadband signals with evolving frequency characteristics.
That organic texture people focused on was mostly a side effect of playback speed. When you speed up a slow-moving physical process, it starts to mimic the rhythm of a heartbeat or a call.
That's worth pushing back on slightly. The analysts flagging biological characteristics weren't guessing from pitch-shifted audio. They were trained signal classifiers, and their initial read deserves more credit than the final explanation tends to give it.
Comparative analysis with later, confirmed ice events placed the bloop within a known family of cryogenic signals, reinforcing the non-biological explanation.
And similar sounds like Julia and train were later attributed to the same general process, ice-related phenomena in the Southern Ocean.
So, in terms of mechanism, nothing about the bloop requires anything outside known geophysical behavior.
It's a classic example of an initially unfamiliar phenomenon. Scary until you have enough data points to recognize the pattern.
The category is probably right, but resolved is doing too much work. The specific event was never directly observed, and the amplitude at that detection range hasn't been cleanly reconciled.
The signal's amplitude was exceptional, but its eventual classification highlights how immense natural, non-biological processes can mimic the unfamiliar.
Which makes perfect sense, given how sparsely mapped the Antarctic acoustic environment was back then.
Still, even within that framework, the exact event behind this particular signal isn't directly observed.
The sheer amplitude still pushes the boundaries of our records. It was a reminder that the deep ocean is a far louder and more dynamic laboratory than we usually give it credit for.
And it hasn't recurred at that profile in 30 years of continued monitoring, which the Icequake explanation doesn't actually account for. It just doesn't rule out.
The Icequake explanation holds, but the amplitude is still notable. It sits at the upper edge of what's been documented.
It's possible we just caught a statistical outlier. The Antarctic cryosphere is massive, and we haven't been listening long enough to see the full range of its power.
The non-recurrence is the part I keep returning to. 30 years of continued monitoring, and nothing at that amplitude and profile combination has reappeared.
Similar signals have been recorded, but none combine that intensity with that particular acoustic profile.
The exceptional detection range and clarity in 1997 probably owed a lot to unusually favorable ocean sound channel conditions that day. Conditions that don't repeat identically every time.
True, but the 1997 event still stands out in how cleanly it was detected across such a wide, vast distance.
We also have to account for the funneling effect of the SOFAR channel, which can make a distant, localized fracture sound like a massive nearby roar, depending on the water's thermal layers.
Right, and that's not a minor caveat. If location is uncertain and no seismic or visual event was ever matched to it, the classification is built entirely on acoustic pattern similarity, nothing else.
The lack of corroboration matters. Classification rests on pattern matching without independent verification.
Still, the waveform match to later, well-documented Antarctic icequakes is tight enough that the acoustic fingerprint is effectively the same family of event.
Yes, though nearly identical, still leaves some room. The original signal had a distinct frequency sweep.
Ice isn't a uniform material. The way it shears and traps air creates a scream that naturally mimics biological vocalizations without needing a living source.
The trained analysts called it organic-like before anyone was trying to make it interesting. That's a data point about the signal, not about public perception.
That organic impression wasn't purely misinterpretation. The signal contained genuine ambiguity.
The biological impression came mostly from limited context and early pitch-shifted playback. Once placed against a proper Antarctic ice library, that impression dissolves.
Agreed. Though even now, the exact mechanics of that specific event aren't fully reconstructed.
We've essentially identified the genus of the sound, but we're still missing the species, the specific physical break that caused it.
That's the honest state of it. A category label with nothing underneath it. No event, no source, no corroboration, just a waveform that resembles other waveforms.
A gap remains between recognizing the phenomenon and reconstructing the precise event.
That specific event precision has stayed elusive because the source was never visually or seismically tagged in real time, and no equivalent single event has matched it blow for blow since. The unresolved element that remains most concerning is how readily an ordinary polar process could register as anomalous when acoustic monitoring is sparse, underscoring both the vast gaps in real-time ocean coverage and the accelerating pace of Antarctic ice loss that will only multiply these signals.
The category seems settled, Icequake, but the specific event still isn't reconstructed.
We don't actually need a frame-by-frame reconstruction of the fracture. The waveform's consistency with known icequake families is already decisive evidence.
Pattern similarity is how you build a hypothesis, not how you confirm one. Those aren't the same thing.
Think of it as forensic ballistics. We've matched the rifling on the sound wave to the Antarctic ice shelf, even if we never found the specific gun that fired it.
The lack of a seismic or visual counterpart isn't trivial. It sets a ceiling on how certain the attribution can be.
Large Antarctic icequakes frequently lack distant seismic detection because the energy couples far more efficiently into the water than into the solid Earth.
But for something this energetic, you might expect at least some corroboration.
That's only if the energy bleeds into the Earth's crust. If the fracture happened in a floating ice tongue, the vibration would be almost entirely dumped into the water column.
Every gap in the evidence gets filled with a propagation assumption, which is a legitimate tool. But at some point, the explanation is load-bearing on inference all the way down.
The triangulation also carries its own uncertainty. The source could lie somewhere other than the calculated point.
The triangulation gives a reliable azimuthal sector, not a pinpoint, so expecting a single, perfectly matched calving scar on satellite imagery from that era is unrealistic.
But it also means we're less certain about where it actually came from.
Positional drift is a feature of deep-sea acoustics, not a bug. The SOFAR channel acts like a hall of mirrors that preserves the what while blurring the where.
It does when the mechanism assignment relies on the location being roughly correct.
And the initial characterization, as possibly biological, wasn't arbitrary. The signal had structural features that made that reading plausible.
The early biological reading stemmed almost entirely from sped-up playback and lack of comparative Antarctic ice sounds. Raw spectrograms never supported an animal source.
Even so, the structure wasn't random. It had a coherent, rising profile.
That rising frequency is just physics. As a crack propagates through ice, the physical dimensions of the vibrating string change, naturally sliding the pitch upward.
Can, yes. Did in this case, at this scale, from this location, that's still an open sentence.
And similar signals, if they exist at that scale, aren't consistently present in the public acoustic record.
Equivalent or larger events are routinely captured now by denser hydrophone networks, but 1997's sparse array and exceptional propagation made this one appear uniquely prominent.
So either it was a rare but natural event.
Or we've been mistaking the comfort of a good category for the weight of actual evidence.
With the available evidence, the gap between a plausible classification and a conclusive one remains.
We're essentially looking at a giant puzzle with one missing piece. We can see the picture of the glacier. We just can't touch the ice that fell.
The acoustic evidence locks it into the Icequake class so firmly that any remaining alternatives require positive contradicting data we simply don't have.
The Icequake explanation is probably right. I just think probably should be said out loud more often than it is.
The singularity of the event is worth noting. There's no clear precedent in the public acoustic record for this exact signal.
Similar sounds were recorded later, but not with the same combination of amplitude and structure.
Singularity in a dataset isn't just a curiosity. It's a problem for any explanation that treats this as a routine instance of a known class.
It doesn't truly stand apart once you account for how variable propagation, array geometry, and background noise can make one instance appear singular, even when the underlying physics is routine.
We also have to consider the survivorship bias of data. For every bloop that goes viral, thousands of similar decibel-shattering events likely occur in unmonitored sectors of the Southern Ocean.
Yet, when you look across available hydrophone data, finding a direct match to that profile remains elusive.
Which suggests either rarity or incomplete sampling.
Both of those are real possibilities, but they're also the two most convenient exits from a question that hasn't been answered.
The match is already strong enough across multiple parameters: duration, frequency evolution, amplitude decay, that insisting on an exact twin waveform is asking for more precision than the physics of variable ice fractures and acoustic paths can realistically deliver.
Agreed. The inference is necessary, but it's based on a dataset that we know is incomplete.
It's like trying to understand an entire language after hearing only a single thunderous shout from across a mountain range.
Which means events of this scale could occur without being consistently captured.
That's plausible, but it's also unfalsifiable in exactly the way that should make us cautious about leaning on it.
There's also the perceptual layer. The sound was described as biological before it was understood.
The biological impression came almost exclusively from time-compressed playback that artificially boosted the sweep into an audible, animal-like moan. Raw, low-frequency spectrograms show nothing resembling marine mammal vocal anatomy.
Right, but the structural qualities that invited that interpretation were present regardless of playback speed.
A rising, coherent frequency over nearly a minute isn't what people intuitively expect from fracturing material.
We often forget that nature includes the mechanical groans of continent-sized ice sheets, which can be just as rhythmic and alive as any whale song.
The flagging wasn't intuitive. It was technical, from people whose job was to not be fooled by intuition.
Which means the ambiguity wasn't just cultural, it was technical.
The technical ambiguity was genuine in 1997 to 2005 because the Antarctic Icequake catalog was tiny. Once that catalog grew, the Bloop profile slotted cleanly into a well-populated family of events.
The data got better. The specific event didn't get explained. Those are different things.
And not an exact reconstruction.
So what remains is a signal that fits a known class, but not perfectly.
It's a best fit solution, scientifically satisfying, because it obeys the laws of physics, even if it lacks the closure of a time-stamped satellite photo of the break.
Close enough to stop looking, which isn't the same thing.
Which leaves one uncomfortable possibility.
That we're confident about what kind of thing it was.
While the actual event, the source, the scale, the moment, remains completely unwitnessed.
We keep coming back to the same point. The explanation works, but not completely.
Categorization is a comfort. It stops the signal from being alien, but it doesn't give us the coordinates of the specific shelf that shattered.
Category fit is the beginning of an explanation, not the end of one.
It doesn't truly stand apart once you account for how variable propagation, array geometry, and background noise can make one instance appear singular, even when the underlying physics is routine.
It leaves a zone of uncertainty that remains open nearly 3 decades later.
And the precision is what's missing.
Precision requires a level of monitoring we simply didn't have in 1997. We're trying to read a blurry photograph from 30 years ago.
If the precision isn't observable, the explanation is a best fit, not a finding. And those carry different weight.
Lack of perfect precision after nearly 30 years is normal for a one-off remote event, captured by a sparse 1990s array. It doesn't constitute evidence of anything beyond ordinary variability.
It leaves a zone of uncertainty that remains open nearly 3 decades later.
No direct observation. No exact reconstruction. No clear repeat.
We have cousins of the Bloop, signals that share the same DNA, but we haven't found its twin.
Similar is doing a lot of work in this conversation.
The family resemblance across dozens of later recorded icequakes is strong enough that demanding an exact waveform duplicate is scientifically unreasonable.
Similar, not identical.
So we have something that fits, but only when viewed from a distance.
And every time we've tried to close the distance, the explanation has gotten vaguer, not sharper.
Complexity is the static in the signal. The more variables you add, water temperature, salinity, seafloor depth, the harder it is to pin down a single, perfect cause.
Or because the explanatory category itself is broad enough to accommodate multiple underlying mechanisms.
The model is appropriately broad because the source process itself is highly variable. Zooming in doesn't reveal mystery. It reveals expected natural scatter.
Maybe.
Or because the single event is the thing that actually needs explaining, and we've been gesturing at the class instead.
A signal that aligns with a known class, yet resists full reduction to any specific event within it.
It's an outlier. But outliers are still part of the natural distribution of a chaotic system like the ocean.
It makes it a named thing we still don't understand.
We can assign it to a category.
We have a label. That's not the same as an explanation, and I think we've been treating it like it is.
We know what it actually was. To the same degree, we know what any untagged, unsighted large Antarctic calving was. A member of a now well-documented class whose individual details are forever lost to time and distance.
And those are not the same answer.
The explanation holds. It sits in place, stable, repeatable, supported by physics and reinforced by later data. Ice moves, fractures, collapses, and the ocean carries that violence farther than we expect. The system works, the model fits, but only at a distance. Up close, the details soften. The exact event is never seen. The source is never fully fixed. The waveform aligns, but not perfectly. Similar signals exist, but not this one. At least not again, not in the same way, not with the same clarity. So the answer becomes a category, not a reconstruction. And that distinction lingers, because this wasn't just a loud sound. It was structured, coherent, rising. Something that, even to trained listeners, briefly crossed into the language of the living before being translated back into the language of ice. The ocean allowed it to travel. The data allowed it to be classified, but nothing allowed it to be fully replayed. And that leaves a quiet gap between what we can explain and what we can actually account for. A signal that fits the model, but only as long as you don't ask exactly what made it.